I've been preparing the chapter Elasticity from physics class 11. I was writing the notes, special notes for the exam, and I marked everything. So the chapter's name, as long as we know, is Elasticity, physics class 11th. And we have elasticity, plasticity, stress, unit of stress, and then more of it. What is the unit of stress? Stress is force by area, so it is the same unit as pressure, Newton per meter square or dyne per centimeter square in CGS. The Newton per meter square in SI unit is also known as Pascal, or in short form PA, capital P and small a. And then the types of stress: longitudinal stress, tangential stress or shearing stress, hydraulic stress or volumetric stress. All the things we have. Most importantly, we have strain. What is strain? Strain is the measure of deformation in a body. So it is mathematically, strain is denoted by the formula change in length by the original length. In case of longitudinal stress, the strain is measured in this way: the change in length due to the application of stress or the application of external force divided by the original length or the initial length. And in this way we have longitudinal strength, which is written by delta L by L. Shearing stress is denoted by delta X by L, where delta X is a change in the displacement and capital L is the original length of the cylinder. Then we have the volume strain, which is equal to delta V by V. Volume strain is related to hydraulic, because when a substance is immersed, or a balloon is immersed, when an inflated balloon is immersed inside a container full of liquid or water, then stress is applied, or an external force is applied from all the sides of the balloon, as a result of which the volume decreases, and this creates a change in volume, and the strain thus formed by the formula of delta V by V is known as the volume strain, which is so volume strain equals to change in volume by the initial volume or original volume. Next we have Hooke's law, very important. Hooke's law establishes the relationship between stress and strain. So what is the relationship? It is denoted by Hooke's law represents that stress is directly proportional to strain. As long when stress increases, the strain also increases, means the deformity also increases. When stress decreases, the deformity also decreases considerably, respectively or consecutively, things like that. Now we see that stress is directly proportional to strain. So stress equal to K into strain. We can write here the K is the proportionality constant, and this constant is also known as the modulus of elasticity. Hooke's law is an empirical law. What is an empirical law? It means that the law which we get from an observation or experimentation. So what is an empirical law? A law which we get from observation and experimentation. But this law is true for some specific criteria, only under specific conditions or under specific criteria. An empirical law cannot be applicable universally. An empirical law is not applicable universally everywhere, so it is not a universal law. Empirical law is not universally applicable. Then we have a graph which is called the stress and strain graph. On the y-axis we have stress, and on the x-axis we have strain. So stress, strain, and this from straight line. The initial straight line indicates elasticity. If the initial is straight line is long enough, then the elasticity is more. Then the initial is gone, then like this, and then like this. The end point E is known as the fracture point. The this upper point, this upper point D is the ultimate strength point, and this OA is the straight linear curve, and then this thing, and then goes this, so after the initial length up to OA is the initial part, and then goes B, and then goes C, and then it again rises up to D, which is the ultimate strain point, and then it ends into the fracture point where it is torn. The substance is torn. It loses completely its elasticity, and as a result it tears down, or it tears. As a result, it is torn up. So the OA is the linear curve, which if is large, it denotes high elastic property, which is seen in case of rubbers. OA curve, which is a linear curve, indicates elasticity. We know that. Here everything is described. We see the point, the lastmost point. You see the straight line, and then a little bit of bend, and then again it rises, and then like this. So at the end, like this, the upper point is D and the fracture point is E. The upper point D is the ultimate strength point, and the ending, which is the E, it is known as the fracture point. If D and E is close to each other, then the substance is easily torn, which denotes that the substance is brittle. Whereas if D point and E point is farther from each other, it means it is far away from each other. It means the substance cannot be easily torn, or cannot be easily torn down, torn up, or teared. So it is very elastic. It has high elastic properties, and it is a ductile material. It has ductile properties. So it will not easily break. It is not at all brittle. Instead, it is more ductile. So further, the points D and E, more ductile is the material. At the fracture point, we have already noticed at the endmost point, the point E, also known as the fracture point. At this point, the substance on which the stress is applied, or on which the strain is observed, or on which the external force is applied, on which the deformity is observed, it tears up. So it is as it is. Next we got the Young modulus. It is too important. For a wire we got Young modulus. Here Young modulus elasticity is denoted by represented by Y, capital Y, which is equal to longitudinal stress sigma by longitudinal strain, which is epsilon. Stress equal to force by area, F by A, and strain equals to delta L by L. It is because longitudinal stuff, so in the longitudinal we get the length, so delta L by L. It is the Young modulus, and if the value of Young modulus for a particular substance is high, if Y is having a greater value, it means that it has more tensile strength. It means that it has more tensile strength. If the F is it means that the force is having a greater value, and the delta L is having a less value, which is resulting in the way that the Y is having a greater value. So it means, in sentence we can write, much high force is required to bring a very small change in the length of the wire. Why am I saying well? It is because everything is said in longitudinal form, so length is more considered in this way. Next, how to find the Young modulus of a wire. It is So wire is actually very thin and long. The shape of a wire is cylindrical. Now y equals to stress by strain. It is because stress equals to K into strain. Here K is the modulus of elasticity, and when we talk about the longitudinal stress by longitudinal strain, the modulus of elasticity becomes Young's modulus of elasticity. So the K is also denoted by Y, capital Y, in case of longitudinal strain by longitudinal strain, and the Y is called the Young modulus of elasticity. Stress equals to F by A and strain equal to delta L by L. The force we can write as weight, which is m into g, mass into gravitational acceleration, which is divided by area of cross section of the wire. We are talking about a wire. So the formula of area of cross section of a wire, we know pi r square, which is whole divided by delta L by L. So we can see that strain has no unit. It is because length is literally divided by length. So strain has no unit and no dimension. Strain is unitless and also dimensionless, whereas stress has a unit which is same. Stress has the same unit which is seen in case of pressure, which is Pascal or Newton per meter square. Now if we talk about what is the unit of Y, what is the unit of Young modulus, what is the unit of modulus of elasticity, we know that Y equal to stress by strain, and strain has no unit and also has no dimension. So the unit of Y is the same unit as the stress. Stress unit is Pascal or Newton per meter square, or PA. So the unit of Young modulus Y is also PA, Pascal or Newton per meter square in SI, and in CGS we get dyne per centimeter square. So we have talked about when Y value is high. Now let's come to the point when Y value is low. When the Y value is low, it means that Y is low. So strain is high but stress is low. It means so if we keep the strain constant, it means the deformity is constant. It means for another substance, for the substance, and for a particular strain, very less amount of stress is applied, or a very less amount of external force is required to apply to in order to observe the same amount of deformity, same range of deformity. Young modulus Y is inversely proportional to strain. Strain is deformation. For next point we have we have the bulk modulus B equals to hydraulic stress by hydraulic strain. Now minus P by delta V by V. Minus P is the pressure applied from all the sides when immersed in the liquid or the fluid, or not fluid, because fluid indicates gases as well as liquids, but liquids is only liquids and water is a liquid. Wow. So what I was talking about, the bulk modulus is represented or is denoted by capital B equals to hydraulic stress by hydraulic strain, minus P by delta V by V. Why there is a minus? It is because the volume always decreases with increase in pressure. When we saw in the longitudinal part, when the external, suppose a wire is hanging from a beam or from a support, when a force is added, when the external force is being added at its end due to gravity, weight is applying downwards, and so the elasticity increases, and so the length of the wire increases. So it is the equation is automatically positive. It is because the length is increasing. Whereas in case of volume, when the force applies in the when immersed in the liquid from all the sides, the volume comparatively decreases. Due to the decrease in volume, we have the negative sign. In case of Young modulus, there was no negative sign. It is because with increase in downward force, with increase in external force, with increase in weight, the length was increasing, the longitudinal length was increasing. But in case of the bulk modulus, in case of hydraulic stress by strain, in case of hydraulic volume matters, the volume is decreasing due to the stress or due to the pressure applied from all the sides when the body is immersed in the liquid. So pressure is inversely proportional to volume V. P is inversely proportional to V. When pressure increases, volume decreases. When pressure decreases, volume increases. The unit is simple again. Bulk modulus is a modulus and it is equal to a stress by strain. Strain has no unit. Strain is unitless and dimensionless. So the unit of stress, which is Newton per meter square in CGS or Pascal, and dyne per centimeter square in CGS. Now, Newton per meter square in SI or Pascal. Newton per meter square or Pascal or PA in case of SI unit, and in case of CGS we in E unit, the unit is dyne per centimeter square. And this was all about the unit and stuff. Next we have the compressibility, which is small k. It is equal to 1 by B, the inverse of the bulk modulus, 1 by capital B. So k is equal to 1 by B equals to minus delta V by V whole by P, pressure. So we can say that the bulk modulus B gives us an idea about compressibility. Yes, it gives. Another thing I learned when I was solving MCQs was elastic potential energy of wire U is equals to half into stress into strain into volume. Half into stress into strain into volume. I think I have to just remember that the elastic potential energy of a wire U equals to half into stress into strain into volume. Just remember it, okay? And also area into length equals to volume. It is because length into length into length equals to volume. Then so I will not show them. Length into length equals to volume. Then area into length equals to volume. It is because area equals to L square, length square. So area into length means length square into length equals to length whole cube, which is volume, equals to L cube, length whole cube. How the hell can we calculate the pressure inside the fluid in case of let's say bulk modulus, when we are calculating or doing sums or maths from the bulk modulus part? We can literally write that the change in pressure, which is delta P equals to rho GD. When the pressure is changing, G and rho is constant, so only the D is changing, which is the height. The height may be the difference in height, height from the above, height from the surface of the water. Done. Whole chapter completed.